Hi, everybody. It's Miss Rose. It's week 26. And guess what? We are about to learn the last new stuff of third quarter. So we're going to spend a few days on this. It's going to be a little unit on trigonometry. It sounds really hard. My big advice is please don't let yourself get intimidated. So this new vocabulary that we're going to be learning, sine, cosine, and tangent. A lot of times people get freaked out thinking this looks so super hard because those are new words that you've never learned before. If you focus really hard on this lesson and you just learn what those vocabulary words represent, they just represent a ratio. It's just vocabulary. Then I think you'll find that this is a piece of cake. Give it a chance. People think it looks hard. There's even a random Mick Jagger song with J-Lo and will.i.am about how hard it is. I'm going to play you a clip. I don't know why they think geometry and trigonometry are so hard, but they just need to give this vocabulary a chance. So first, I just want to show you why we're learning trigonometry. So you might be like, hey, this looks just like what we learned last week. So it is. The first one's a 45, 45, 90 triangle. And we learned that if one of the legs is 10, the other leg is 10, and then the hypotenuse is 10 root 2. And we could find the missing sides. And then the other one with the 60-degree angle, it was a 30, 60, 90. So that we learned that the short leg was half the hypotenuse. And then we can put a root 3 on it. And that's the long leg. But then we get to 37 degrees. And that one wasn't one of the special ones that we learned. So here's how I think about it is like, well, if it was 30 degrees, this would be 9. But it's 37 degrees. So it's a little more than 9. It's probably like 10-ish. But how do you calculate that? That's where trigonometry comes in. So in this lesson, I'm just going to give you a little intro on the vocab and what it means and how to start using it. And then in the next lesson, we'll solve problems like this, where we can actually use trigonometry to find missing sides in a triangle if we're given angles other than 30 or 60 or 45. All right, first we need to learn some important vocab. So first off with this sine, cosine, and tangent, I know it looks like sin, but it's an abbreviation, so it's sine. So make sure that that's how you're pronouncing it. Sine, cosine, and tangent. First thing that I want you to notice is we always give you some sort of input. A lot of times we even put it in parentheses. We'll go like sine of A. And that just tells you which angle you're supposed to be looking at. So for all of these problems here, notice that angle A is the input for all of them. So that's the angle that I'm going to be focusing on. So first, make a little sketch of this triangle. I want you to identify which side is the hypotenuse. And hopefully you say, great, that's AB, because it's the side opposite the 90-degree angle. All right, here's where the important thing comes in for focusing on angle A. We have different names for the two legs, so it's important to identify which one is which. So we're going to talk about the opposite leg. So if we're talking about angle A, the opposite leg is different than if we're talking about angle B. Here's what the opposite leg is. If you took an arrow from angle A and you shot it across the triangle, that would be the opposite side. It's the side that doesn't touch the A. So that's the opposite leg. The other leg that does touch the A, that's called the adjacent leg. A lot of times adjacent is just next to, like your house is adjacent to your next door neighbor's house. So in these problems, it's going to be important to first identify which vocabulary word is which. And then now I'm going to teach you what these different new vocabulary words actually mean. So I'm going to switch colors. And you just need to know that whenever you see sine, all it means is that you take the opposite leg over the hypotenuse, and that fraction is your answer for sine. So instead of writing opposite leg and hypotenuse, I'm just going to write O and H. So when I talk about O, I'm talking about the opposite leg. And when I'm talking about H, I'm talking about the hypotenuse. Cosine. You just need to know every time we use the word cosine, we're just talking about the fraction of adjacent leg over hypotenuse. And then when we talk about tangent, the tangent's actually the sine over the cosine. The H's would cancel out. Tangent is O over A, opposite over adjacent. The hypotenuse doesn't get used at all. So that's all that we're talking about. When we say what's the sine of angle A, we just want you to give us the fraction. It's really important that you memorize these definitions. So there's this made up word that a lot of people use to memorize this called SOHCAHTOA. The problem with that is if I said to you, how do you spell SOHCAHTOA? I doubt any of you would guess that you spell it this way. So some people use a little saying to help them. The saying actually is not classroom appropriate. So Mr. Millington and I made up our own clean version of the saying. Here's what it is. S is for sine, C is for cosine, T is for tangent. So here's the saying. It's some old hippie caught another hippie tripping over apples. And if you can remember that saying, then you'll remember that sine is O over H, cosine is A over H, and tangent is O over A. So what does that actually mean when it comes to triangles with real numbers on it? So let's take a look at an example. So this would be really good to write down. So first off, you might notice I only gave you 2 out of the 3 sides in the triangle. So the first thing that we have to do is find the missing side, which means we have to use Pythagorean theorem. So that's going to come back. X and 15 are the legs. X squared plus 15 squared equals 17 squared. If you are starting to learn your Pythagorean triples, you'll know that this is one of those examples that actually works out nicely. So once we start to have those memorized, sometimes you don't need to do any calculations. You'll just know what the missing side length is. So when I square root, I get 8. So if you know that 8, 15, 17 is a Pythagorean triple, then you can save that step of doing the Pythagorean theorem. Okay, next, notice that for all of these examples, I'm using C. So I would circle the C, and then we're going to label the O, the A, and the H. I do the H first because we all know what the hypotenuse is. Then I do the O because I shoot an arrow across from the C, and that's the opposite leg. And then I do the A last, the adjacent leg. Then I write my SOHCAHTOA on the top of my paper. I'm going to switch colors. That one is very thick. All right, let's pick a normal size. Some old hippie caught another hippie tripping over apples. All right, this is all you do. Ready? Sine O over H, 8 over 17. I'm just using my O number and my H number. See? 8, 17, done. That's the answer. All right, cosine A over H. I just take my A number and my H number. 15 over 17. Done. That's the answer. Then finally, tangent. Tripping over apples. Tangent O over A. So I just take my O number, my A number, and I make that fraction. 8 over 15. Done. So see what I mean? All we're looking for is the fraction. Don't make too much of it. You might be wondering, well, what does that actually help you to do? We need to learn this first. Then I promise we will show you how you can use these things to help you to find missing side lengths and angle measures and all that good stuff. For now, we're just looking for the fractions. All right, here's another example. What if we give you the sine? What does that tell you? Well, first off, this is right triangle trigonometry. So every problem that we're going to be doing is related to a right triangle. So first, that's what I would do. Then it says sine of A. So we'll put an angle A on here. It doesn't matter which angle you pick, just don't pick the right angle. So I'm going to pick this one down here to be my A. I don't know what this is. I'll just call it triangle ABC. All that matters is where the A is. So I'm going to write my SOHCAHTOA down. Some old hippie caught another hippie tripping over apples. All right, sine is O over H. So O over H is 3 over 5. O and H. That means 3 is the O, which is opposite angle A. So I'm going to go opposite angle A and put 3. Hypotenuse, H, is 5. And then I need to know the missing side in the triangle, so I need to do Pythagorean theorem again. 3 squared plus x squared equals 5 squared. This one's usually the first one that people have memorized. It's a 3, 4, 5 triangle. So if you know that, you don't have to do all this work to do the Pythagorean theorem. You'll just know that the missing side is 4. All right, so the question said, what is the cosine of A? So we're looking at A again. Cosine in our SOHCAHTOA is adjacent over hypotenuse. So we had 3 was the opposite, 5 was the hypotenuse, so 4 is the adjacent. So all we have to do to answer this cosine question, cosine of A, is just to make our A over H fraction, 4 over 5. All right, here's a little secret. Just because the sine is 3/5 doesn't mean that the side lengths are actually 3 and 5. It just means that that's the simplified fraction. So they might be 3 and 5, they might be 6 and 10, they might be 9 and 15. We don't know. So that's what the second part of the problem is talking about. It says that the perimeter of the triangle is 60. I'm going to find our perimeter, 3 plus 4 plus 5, and it's only 12. So we need to do something with scale factor or setting up a proportion. So I'm going to say, well, our triangle has a perimeter of 12. This one is supposed to have a perimeter of 60. And then it says find the length of the actual hypotenuse. Well, our hypotenuse in our triangle was 5. So I'm going to put 5 over x. So I did our triangle over the actual triangle. So 12 in our triangle over 60 for the actual triangle. 5 in our triangle over x. Or you could use scale factor too. That would be another good way to do this. All right, 60 times 5 is 300. 300 divided by 12 is 25. So that's the actual hypotenuse of the triangle. So really, instead of 3, 4, 5, the side lengths are 15, 20, and 25. All right, I have one last one for you. I know this is a lot of new material thrown at you, but now we're going to have a chance to do a little practice on this stuff after these examples. It says find the tangent of 45 and find the tangent of 30. So instead of like find tan A, it says find tan 45. So first step I mentioned in the last problem is you have to make a right triangle. If one of the angles is 45, that means it's a 45, 45, 90. This is kind of interesting. We could use numbers as an example, or we can use x's. I'm going to go x, x, x root 2. That's what we learned the pattern was in a 45, 45, 90. So tan 45 is, well, let's write down SOHCAHTOA again and remember what tan is. It's O over A. Well, let's pick one of the 45s. The O, opposite leg, is x. And A, the adjacent leg, is also x. So this is kind of weird. It's x over x. Well, what do you get when you divide something by itself? You get 1. So if you typed tan 45 in a calculator, which we'll show you how to do in a little while, you'd actually get 1 as your answer. Let's try to do the same thing for a 30 degree. Notice that I picked only numbers that come in our special triangles. So for the 30, 60, 90s, we learned that the short leg is x. You double it to get the hypotenuse, so that's 2x. And you take the short leg and put a root 3 on it, and that's your long leg. So we want to know cosine. Cosine is A over H. So H is the 2x, and then which leg is adjacent to 30? Well, x is opposite, so x root 3 is adjacent. So cosine 30 equals A, which is x root 3, over H, which is 2x. And the x's cancel out, so it equals root 3 over 2. So if you typed cosine 30 into a calculator and then you typed root 3 over 2 into a calculator, the decimals would match. So let's do some practice. And the more we practice, the more we're going to get used to this new vocabulary. Thanks for watching.